All right, section 5.4 is about medians and altitudes. Again, I'm going to remind you that you have the study guides, you have the pages from the list. And actually, I ask you to do quite a bit of practice for 5.4. I ask you to do some from practice A as well as some from practice B. So it's a median, not to be confused with a mid-segment. Remember, a mid-segment connects the midpoints of two sides. A median goes from a vertex to the midpoint of the opposite side. So if F is the midpoint of BC, the median is drawn from the vertex to the midpoint of the opposite side. So here, if E was the midpoint of AC, I would draw that from B to E. That's another median. And then if I found the midpoint of AG, and again, there's a point of concurrency, and that is called the centroid. And it's essentially the balance point. If you were to try to balance, if I cut this triangle out and balanced it on the pencil, that would be the balancing point. If you put it up here, how would it balance? So that's the centroid, the point of concurrency of the three medians. Especially centroid, that is AP is 2/3 AF. So from the vertex, this can be a little confusing, from the vertex to the centroid is 2/3 of the median. And actually, if you break it down, it makes it a little bit sort of simple. So if this is 8, this is 2/3, this is 1/3, this has to be twice as big as that. So if this is 8, this has to be 4. I think that's actually use the first 2/3 of. So for example, this was 7, it just has to be twice that. That's 3.5. So I sort of feel like that's an easier way to measure it. So here's a problem where Q is the centroid. Told that Q is a centroid. And so it's telling that SQ is 8. What must QW be? Oh, I just did that kind of. That has to be 4. And therefore, so QW equals 4. And SW must be 12. If I had said Q is 2/3 SW, then 8 is 2/3 SW, and then I would multiply both sides by 3/2. 8 divided by 2 is 4, 4 SW. But it's way easier to just label that 8, know that that's half of that, and then add them together. If WT is 10, how big is RW? Well, don't forget what is S. This is congruent to that. From a vertex to the midpoint of the opposite side. So this is the midpoint, that's 10. That has to be 10. So that'll help you with some of the problem solving. Coordinate geometry. Good, particularly standardized tests. So if I want to find the midpoint of GH. Now, there is a midpoint formula, but I'm not a big fan of the midpoint formula. It's not a midpoint formula. So if I want to go find the midpoint here, I have to go halfway between G and H. Well, how far is it from 4 to 6? It's 2. So if I only want to go halfway, then I only want, so 5. And how far is it from 1 to 9? Well, that's 8. So if I only want to go halfway, 4, 1, 2, 3, 4. So 4 from 9 is 5, or 4 from 1 is 5. Whoops. So the midpoint 5, 5. Now, if you use the mid formula is x1 plus x2 over 2, y1 plus y2 over 2. So I would have 4 plus 6 over 2, which is indeed 5. And I'd have 9. That's the midpoint formula. But the other nice thing about this is how long that was, GH. Well, there's the squared plus 8 squared would equal GH squared. The triangles, they can be used for everything already in your head, and you can draw them on here. And it's a centroid P. The centroid has to be, so if I go from F to the mid H, well, this is 3 units long, 2 from that, so that would have 2, 3, 4. The coordinates of the centroid P would be 4, 5. Problem, they might just give you the coordinates. Negative 1, 2, 1, 2, 3, 4, 5, 1, 3, 4, 6, and then 5, negative 2. So there's my triangle. If I wanted to notice this beautiful vertical line, should be halfway. So this is negative 1, 2, 6. This is 5, negative 2. And again, this is 8. So how far would halfway be? 1, 2, 3, 4. I know its x coordinate is 5. I know its coordinate 2 on median. And it has to be, or is it 1, 5? That's 6. And again, you could count it. You know, that's 2/3 of that. If I were to break that into something that was 2 times that, 4 and 2, right? 4 and 2. The other out of 6. So this would have to be 3 from negative 1, 4 spaces. But I also want to show this is where my right triangles come into play. 5 of S. So here's 5 triangle. 5 to 11 is 6. From 5 to 3. So how far do I need to go in the x direction? 5 plus 3. How far do I need to go down in the y direction? 4, 5, 8, 1. Must be 8, 1. Again, if you use mid, 11 over 2, 5, 2, and you would get 16 over 2 is 8. It is the point formula, but I love my right triangles. Nice. I hope there's nothing on practice B that's a little too whole segment must be 9. So if I was to be 6 and 3, 6, 5. Or you could and again, my y coordinate is 1. 1. Find P, the midpoint of ST. We already find R, the midpoint of TU. You could 11. Well, again, you could 1 minus 3 is negative 2. Half of that is negative 1. midpoint there is 5, -1. And then they want you to verify 2/3, that's 1/3. See how all that beautiful coordinate geometry works. Centroids, 2/3, another in here is altitudes. What is an altitude? Height of a triangle. So an altitude, if a midpoint median from the vertex to the midpoint of the opposite side, and vertex perpendicular to the other side, and we often do. And the 3 altitudes of a triangle, the orthocenter, special name, but I don't. Does I think I looked it up once. Something about orthogonal. Let's look at a scalene triangle, though. If I have a scalene triangle, 3, 2, there's one. That looks like the other one. So in a scalene triangle, there's my orthocenter. It's in the triangle. In a right triangle, our legs, there's one, there's the other, and then they meet right there. Circle center is not the in center. Could look it up. Triangle. Now this altitude's pretty easy. From this vertex to this side, well, I have to. I can on my altitude. Red. And I'm going to have to extend these to find out where they from this vertex to this side. So again, I have to extend perpendicularly to it. So some altitude triangle, and these guys would all meet. That orthocenter would be out there. What kind of things have to identify things like is it an altitude? Bisector. Notice this is an altitude and it's perpendicular. This is perpendicular to AC, but it doesn't bisect. What kind of triangle would that happen? And it's distinguish and compare these 3.